Okay, welcome. This is going to be a quick video. I'm going to just call this part 2 of micro clamp sensors, scopes, and pin fitment. And you saw the first video. If you have not, you probably want to watch that before this. We're in the same similar setup. The only time this time we're going to use 3 channels, and we are going to concentrate on the signal wire from the cam sensor to the PCM. We have the micro clamp moved from the power feed to the signal wire with the arrow on the micro clamp pointing in the direction from the PCM toward the cam sensor. Our channel, that's channel A. Channel B is we're picking up the cam sensor signal at the PCM, and channel C green is that we're picking up the cam signal at the cam sensor. In between is a connector with 3 pins, and we're going to talk about when pin fitment becomes intermittently compromised, what it looks like, and how to our diagnostic advantage the micro clamp can be when we're diagnosing a no start or a code or a cam sensor input issue or a correlation issue, something involving any kind of rotating sensor like this, which is a 3-wire sensor, which it's power fed at the top, as you can see from the red part of the illustration that comes from a relay. The middle signal, the sort of teal colored wire, it's not that color on the car, but nonetheless that's in the illustration that is the signal wire from the cam sensor to the PCM, and it is a hard ground going through the connector and onto ground. I will take you to the scope, and we will see what we look like. We're going to start the vehicle, and we're going to create a situation where we have a pin fitment issue. What you see on the scope is sort of that's a frozen previous capture. And let's get some. I kind of got chopped off in the last video. I apologize. That was my bad. Kind of bummed me out. I'm going to try not to let that happen this time, so you can see the whole scope. Okay, so we're on the scope. We're frozen. So I'm gonna start the scope and start the car and take a normal capture. We'll talk about how everything is set up once we get running. So let's take a look. Starting the car. Okay, you can see what we got. Now I'll stop the scope and stop the car, and we'll talk about it and analyze the signal. Okay, as you can look at your illustration, you can see the 3 signals. Blue is our micro clamp. That's down here. That is, I did have to use some vertical zoom because it's such a small amount of current. Even I'm using a very sensitive clamp, the micro clamp. I stretched it a little bit, but nonetheless, it's there. It's very, very, very definable. And so that is channel A. That is the current flowing. As we can see, that's actually flowing from the PCM to the cam sensor, and the cam sensor and the sensor is rotating, and it's moving the signal. It's pulsing it to ground. We'll see that once we start looking at it dynamically. Channel B red is the cam sensor at the PCM. Channel C green is the cam sensor signal at the cam sensor. So as we can look, let's roll it back to the beginning of the capture. Here we go, and we'll analyze it. It's basically a 0 to 5. That's why I start the car, and you can see right here, this is a normal signal. This is like a 0 to 5. It meets the threshold that the PCM requires. It has to reach a certain threshold. You can't be shallow or shy of 1.5 volts. It won't pick up the signal. The current is you can see the current being a ground side switch sensor. When the sensor goes low, the current will flow. So nonetheless, we can see our current is flowing right here. Right here, it is pulsing as the sensor makes and breaks the circuit. It is a 3-wire magnetoresistive type sensor. And there I pick up speed, and we got a little more, we don't see any breakouts. We're all clean, no anomalies, everything good. So that's that. Right now what I'm gonna do is I'm gonna make and break. I'm gonna create a pin fitment issue only at the middle pin. That's the pin, the signal wire between the cam sensor and the PCM. If you look at your schematic, you see the 3 pins, and we're gonna see what happens if we had a break in this wire intermittently. what happens, what can we infer from our scope pattern. So let me start the scope and start the car, and we will create an intermittent. Okay, going across the screen now. Take a look at the screen. Okay, we got our scope pattern there. Okay, let me stop the scope and analyze. Okay, so we saw some intermittent action. Let's go back to the first screen and take a look. And you know what a good screen looks like from the previous capture. Okay, all right, now we're going across the screen and we're looking good. We're square on each corner. Our current is flowing. Our signal is, we're testing the same signal at two different points in the circuit, at the cam sensor and at the PCM. Sometimes that works to our diagnostic advantage when we have a multiple channel scope, because there could be something happening between those test points. But nonetheless, it's back here. We're going to go to where we encounter some intermittence. Okay, there's where we broke circuit. That's that intermittent pin fitment issue at that connector. And let's take a look at everything now. Let's take a look at our current. Right from this, we can tell our current stopped flowing because we had an open circuit down at the, that's pretty much zero. And that's about 1.5 milliamps. That's a pretty sensitive clamp. It's one of those real sensitive clamps that the AMAC K100, and it's pretty sensitive. So when we open circuited, we know our current stopped flowing, and look at our green and our red. From our test point at the PCM, we could deduce that 5 volts is coming from the PCM, and the cam sensor is receiving it. Being the fact that the voltage is 5 volts on red and 0 on the green. So nonetheless, if we ever had a question of way which current is flowing, I always said a micro clamp is really advantageous, because sometimes we have a transistor to they call it logic or communication, and it's always been kind of hard to decipher who's providing the current and who's receiving the current. So nonetheless, this micro clamp sort of tells us that the PCM pushes the 5 volts out, and the cam sensor chops it to ground to make this signal. So anyway, let me go back, go through the capture, and you could see this is where we remain intermittent. You could see this, so we know we right in our intermittent, our gap zone, we know we would have an open in that wire somewhere. It could be open internal to the cam sensor, internal to the PCM, or the wire itself, by putting that micro clamp between there. So anyway, I just wanted to add this second video to the first one, because I think this is pretty important to cover the way we're able to get resolution with a very sensitive clamp. But just point out that I did have to use a lot of vertical zoom on blue, and the scope allows us to do that. But nonetheless, it's a pretty square looking signal. And anyway, all the best. This is another technical technician video from Diagnation, and take care.